Let's go ahead and start by defining what a situational graph is. We compare two variables and how they relate to each other on a graph. And I didn't need to rewrite graph because it's right there. Okay? And we're going to describe what is happening during each interval of Shelly's walk home. So in this scenario, we have a girl named Shelly and she is walking home, and we're just going to interpret what this graph is telling us. So I see that this is the time and this is the distance from home. So Shelly is actually not at home when the graph starts. Okay, then she starts on her way home. She goes in the opposite direction. Something else happens at 3 that we'll discuss. Then she starts home again. She does something else. She goes away from home. She does something else. And then she finally makes it home by the end. So we're going to go ahead and interpret this situational graph. It's asking me here in the box to describe and include speed and direction. At the interval 1, which is here to here, they want me to describe that, including speed and direction. So I'm going to say she is going towards home. And I don't know how fast she's going because I don't have anything to compare it to yet. So once she gets to interval 2, which is from here to here, I see that she is going away from home, and I'm going to say quickly. And I can compare this because it took her this much time to travel from here. I'm sorry, it took her this much time to travel from here to here. But then when she started going away from home, she actually traveled that same distance because she's back up here, but she did it in way less time. So I know that's how I know that she's traveling really quickly. Then at 3, there's a line straight across, and this is basically telling me that she's not traveling any distance, but time is still going. So that tells me that she stopped at this point. And we don't need to include speed because she stopped. There's no direction. She's just stopped. Okay, at the interval 4, which is from here to here, we can assume that she is going towards home again. And I'm going to say this is a constant rate, maybe walking, not fast at all. And then in interval 5, from here to here, she stopped again. Interval 6, she's traveling away from home. I really can't say how fast or slow she's doing that. It's hard to tell. 7, she stopped again. And 8, she finally went home. And I know that that's very fast because this is the halfway point. And just in this last little bit of time, she traveled all the way halfway home from where she began way up here. So I know that she went very quickly home. That's just one example, and that was just interpreting what each interval meant. Now we're going to go ahead and we're going to write out and fill in the blanks. During which interval is the graph increasing? Let me explain what increasing is. Anytime we're going up, that's increasing. Anytime we're going the direction of down, that's decreasing. So during which intervals is the graph increasing? I see that it's increasing here, which is interval 2, and again here in interval 6. We read left to right in the English language and in mathematics, so we wouldn't say that it's increasing on interval 4 because that would be going backwards even though it's going up. We don't read from right to left, we read left to right. Okay, just in case you're confused about that. The next thing is asking us is, what does that mean on this graph? Well, when it's increasing, I see that that means on this graph, she's traveling away from home. Now, in which interval is she decreasing? Decreasing is in the down direction, like we mentioned before. And so I can see that she's decreasing at interval 1, again at interval 4, and again at interval 8. What does that mean on this graph? Well, when she's going down, she's actually getting closer to home. So she's going towards home. Next, it's asking us, where is the graph constant? Constant means she's not getting closer or farther away from home, and I can see that that's at 3, 5, and 7. 3, 5, and 7. What does that mean? It means that she's basically stopped. Below, we have another scenario asking us to find the reasonable domain and range. And domain is all the x values, and the range is all the y values. A ball was kicked in the air. There's the ball, and it's kicked in the air. In this scenario, I'm going to be creative, and I'm going to say I want to compare time and the height of the ball. Just to be a little more specific, this means all the x values. I know that x is down here and y is over here from things we studied earlier last week. So all the x values go from here to here. That's from, and again that's the domain, from 0 to 5. And we're going to write this in inequality notation. And I know that this is the x value because it's my independent variable. Now, it went from 0 to 5 and it included 0 to 5. So x is greater than 0 and less than 5, but it's also equal to, because we can see it started at 0 and ended at 5. Next, we're going to do the range, and it went from 0 again, but this time it went up here, and we're going to let this be 6.25 just for ease. So that's 6.25. And what's our variable that goes in the middle? Y, because we're talking about the range. That's also going to have the equal to symbol because it includes 0 again, and it includes 6.25. Okay, we have a couple more examples to look at the bottom. We're going to choose the best graph for the given situations and label the axis of the chosen graph with the variables given in the parentheses. So in the first example, Katie walked from home to the library, did some homework, then walked back. So she's actually walking from home. Then she gets to the library, did some homework, then walked back. So which one of these would represent that? Okay, she's going to start at home. So they all start at home. And then she gets somewhere else, so to the library. They all work out at this. Well, this one doesn't start from home, so that's out as far as number 1. And then it says she gets to the library and she does some homework. Well, if she's at the library, she's actually not doing any movement, so she's constant. So both of these work out so far. But then it says she went back home. So she would need to be going back home. So for number 1, the one that works is G. Okay, for the second scenario, Katie walked from home to the library. And this time we're comparing speed and time. She did some homework and then walked back. So we already know this one is taken for number 1. Since we're comparing speed to time, time is going to again be on the bottom and speed is going to be over here. And she walked from home. She's actually not stopped. So we can't start at 0 on speed. Speed, she would at least have to be walking. So she would be walking and then all of a sudden she's not walking. So we don't gradually go down. We immediately go down because then she's not moving at all. She studies. Time is still passing, but she's not moving as far as speed goes. And then she walks back home. So she's back up here all of a sudden because she's moving again. And then she ends up at home. So that is how this one would work. And again, we said this is time. and this is speed. So number 2 is O.